Here's a graphing parabola example. You'll notice here is our original. It's already written in standard form. The first thing I'm going to want to do for this example is I'm going to want to find the equation for my axis of symmetry. So axis of symmetry is always x equals negative b over 2a. It's a formula that you have to have memorized. So I know my negative b, my b value is always in front of my x variable. So that's going to be 4 over 2 times a. My a value is going to be the number in front of the x squared. We just have a negative, so we assume that it's negative 1. So this gets us negative 4 over negative 2. So our axis of symmetry is going to simplify to positive 2. So x equals 2 is our axis of symmetry. So what we're going to do is we're going to look at our x-axis and we're going to graph a vertical dotted line that goes through the x-axis at 2. The reason why we're going to do that is because this is the axis of symmetry. This is the middle of the graph. The middle of the graph tells us a lot because later on we're going to find points and actually reflect those points. That way we're going to make our lives a little bit easier. The next thing we're going to find is the vertex. Now the vertex occurs in the middle of the graph. I know for my vertex, my x value is going to be the same as my axis of symmetry x value. All I have to do at this point right now is find the y. So y equals negative x squared plus 4x. I almost forgot my parentheses there. Plus 4x plus 3. I'm going to plug in my 2 value to both of these x's. Remember, I'm going to make that in red just because I want it to stand out. That 2 value is the same as my axis of symmetry 2 because these two things are actually in the same location. Our vertex will be along this axis of symmetry once we actually graph it. So when we simplify, we're going to end up getting negative 4. We always do exponents first, then we multiply by our coefficient. Plus 8 plus 3. So my y value is actually going to end up getting positive 4 plus 3. That's going to be 7. So 7 is my y value of the vertex. So I have to go over 2 from the origin, so over 2. Up 7. I hope my graph is big enough. 1, 2, 3, 4, 5, 6, 7. Just barely. So here is my vertex. It is on the axis of symmetry. That is the middle of my graph. Now I'm going to do the easiest part, my favorite part, the y-intercept. I know that's the c value. The c value of this equation can be found. I'm going to actually use my little arrow here. If we go up here, the c value is going to be our number that is not attached to a variable in the original equation. So right there. C is equal to 3. That means on my y-axis, up 3 is where this graph is going to cross the y-axis, up 3. Now we got this awesome symmetry here going. This is the middle. This red line is the middle of the graph. I know I have 1 point over here, 2 points away from the axis of symmetry. So I know I must have another point 2 points away from that axis of symmetry. So I'm going to draw a little X just to show, hey, this is where my other point's going to be. Anytime I draw an X for a point, I'm just going to use that as a reference for you later on to see that, oh, that's because of symmetry. So I'm going to do the rest of this graph in a table because I'm looking at this right now and I have 1, 2, 3 points. So I have 3 points. I really want 5 because a lot of the problems are going to require 5 points. So in order to get another point, I really only need 1 more. But in order to get another point, I'm actually going to create a table. So here's my X. I have to plug it into negative x squared plus 4x plus 3. And then I'm going to get my y value. And the reason why I said we only really need one more point, because here we have a total, oh, that's a lightsaber. I didn't even realize that. That's awesome. Here we have a total of 3 points. I need 5. So I need a total of 5 points. There's a blue lightsaber. Yeah, that's awesome. That's really cool. Hang on, I got one more on here. There we go. That's awesome. So I need a total of 5 points. I already have 3. If I make 1 point on one side, I can easily reflect it to the other side. So I'm going to do that, and I'm going to use a lightsaber going in another direction to show I may actually want to use my X value of 1, only because it's kind of close to the axis of symmetry there. Kind of close. I could do 3 and then reflect it to the other side, but 3 is bigger and I like small numbers. So I'm going to plug in 1. I'm going to show my work in the middle. You don't always have to do your tables like this, but I like that. Plus 4 times 1 plus 3. And I just like to use this middle part to kind of show my work. So I get negative 1 squared is 1 plus 4. That gets me 3 plus 3 is 6. So my next point is on 1 comma 6. So if I go over 1 and up 6, I end up getting a point right here. I can reflect this point to the other side of my axis of symmetry and get a point right here. And then you'll notice, and I'll do this in a light blue, or actually I'll do this in black. You'll notice the parabola is formed. So there's the parabola. That's about what it looks like right there. I like to put arrows on both sides to show that it goes down forever. So just to summarize, using my new favorite tool on here, this lightsaber, let's do a green lightsaber. Awesome. So we started here with our original equation. Then we found the axis of symmetry given this formula. That's a formula that you have to have memorized. The next step is to find the vertex. You find the vertex by taking your axis of symmetry and plugging it into your original function, whatever that may be. Then you find the y-intercept, c equals 3. That's the easiest part. Keep in mind that I plotted all these things as I went along. So I plotted my axis of symmetry, I plotted my vertex, and I plotted my y-intercept. What I did is I used symmetry in order to find these points as well. So I used symmetry in order to find those 2 points. Lastly, I needed another point. I needed 2 more points because I wanted a total of 5. So right here is where I created my table. I plug in a number for x. I simplify. I get my value right here. I can reflect it to the other side, and there is a parabola graphing a minimum of 5 points.